Hi, we are here and we will like to calculate in this problem the moment that these two forces produce. And as you see, those two forces have the same magnitude, opposite sense, and same direction. So they are parallel to each other, but they have opposite sense. Therefore, there are a couple of forces, and we will be able to calculate the moment, as you recall, for scalar approach. If we have two forces in same magnitude, the moment will be distance times force, where distance is perpendicular to force. In vector approach, we will have our two forces and the distance that separate those forces. So we will choose one point, for example, point A, and this is point B. So this will be my vector A, B. So I will place my origin at A, and the moment will be RAB cross F. Which F? This one right here. So I go from here to there and multiply by this F. I could do it opposite. I could say the same, and I could go from B to A, and then I will use this force over here. So if we name this force B and this force A, this will be times B. And we can calculate it as also the moment will be RB A cross A. And I will have exact the same result. So I place my origin of the distance in one of the forces, take that vector and multiply by the force. So if we go back to our example, we can say, well, my moment, which will be the couple moment, since it's 3D, I would rather use the vector approach. I will use from A, let me mark it, let me see which color looks better here, this one. From A to B, this will be RAB, and I will use force B. So therefore, my moment will be equals to RAB cross FB. As I said, we could do the opposite, which we will do after, but I will take my origin at one of the forces, in this case A, take the distance, which is a vector, and multiply by this force over here. Therefore, I need those two vectors. This vector will be from A to B. You see that this is parallel to I, and this distance is given. If we look at our figure, this distance is 0.4 meters, and therefore RB is 0.4 in I meters, right? And then I need this force FB. FB will be equals to the magnitude of the force, and in order to find the directions, this angle over here will be the same as this angle over here. So therefore, I can decompose the force in my Y component and in my C component. The Y component will be the cosine of this angle, and the cosine of this angle will be 4 over 5 in J direction, and then I have multiplied by sine will be in my negative C direction. And this will be in newtons. Therefore, if I do this multiplication, I get 360J, and in K I have negative 270 in K. All that in newtons. And this, as I say, is a vector. So we have these two vectors. Now we just have to multiply those two vectors. We can use matrix or we can use the distributive property, but in any case, my moment as a vector will be equals to RB cross FB. If I use a matrix, will be I, J, K. My first row will be the first vector, so it's 0.5 over here, 0, 0, and my third row will be my fourth, right? 360 minus 270. And as you recall, we multiply I times this determinant, which gives me 0. In J, remember that it's negative J, 0.4 times negative 270 times this column over here. And then we have K. So at the end we have, in I we got 0, in J we got negative 0.4 times negative 70. So that's is in J. And in K we have this one here, which will be positive 0.4 times 360. That's K. Finally, my moment will be equals to, as a vector, this multiplication gives me a positive number, 108 in J, and this one gives me also a positive number, 144K, and the units, remember, that are distance times force, which are newtons times meters. And this is the result. So we were able to calculate the moment, and if you see, the direction has a component in J and a component in K, and it doesn't have any component in I. So it's parallel to the plane JC. So if we like to draw that moment, will be something like, it's difficult to draw it right here, but it will be in the direction of the plane JC, which has a positive component in J and a positive component in C. If we like to use the other approach, it means, let me write here, other approach. And you have to only choose one, so that will be the solution of this problem. But if you want to use other approach, will be M equals, now I go to the opposite direction, from B to A cross FA. And then BA will be negative 0.4 I, because I'm going in this direction now, and FA will be negative in J and positive in C. So it will be very similar to that, but it will be negative 360 in J plus 270 in K. And if I do this multiplication, I, J, K, and then I do negative 0.400, and I have 0, 360 negative and 270 positive. If you do that multiplication, this is a vector, you will get exact the same answer, which is 108. So please do the multiplications, and you will see that you get exact the same answer. So you have to choose either approach, not both, and you will get exactly the same answer. And this is the solution of this problem.